Hey everyone, welcome back. Today is day 4 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on video. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning. I ranked globally in top zero point 0.3 on LeetCode, and like most of you, I'm also preparing for FAANG interviews. So far, we have covered sliding windows, two pointers, partition, and prefix and suffix patterns. Today, we are diving deep into string problems and we'll solve problems based on substrings, character counts, anagrams, and all the classic tricks interviewers love to test. Before I begin, if you find this video helpful, please drop a like and share it with your friends who is also preparing. And please hit that subscribe button so that we can crack the interviews side by side. Let us go. So today we will be tackling LeetCode 5, which is longest palindromic substring. And the problem states that we have been given a string and we have to return the longest palindromic substring that is present in that string. The constraints are as follows. The length is bounded within 1000 and S contains only the English letters, which is 42, including both lowercase and the uppercase. Okay, let us try to investigate and solve this problem in an optimal manner. I will not waste a lot of time on this problem because this problem is almost identical to the previous problem that we've solved 647 on LeetCode. You can watch my previous video for day 4. So I'll directly jump to the problem and its solution. Okay. So we have been given a string S and we have to return the longest substring such that it is a palindrome. Okay. For example, in this case, what could that string be? That string could be ABA because it is a palindromic substring of length 3, or it could be BAB because it is also palindromic substring of length 3. Can we return BABA? No, because it is not a substring, because it is not a palindrome, because B is not equivalent to A. Okay. And we just have to return only one such longest substring. Okay. Now, as I explained in the previous video in LeetCode 647 on day 4, just the previous one, I told you that if I am at any given index, I will have two choices. First choice will be to shift the left pointer to the left by 1 and to shift the right pointer to the right by 1. But in order to accomplish that, there are two cases that we need to take care of. The first cases will be the even case, considering the substring is of length even, and the second case will be the odd case, considering or assuming that the substring that we are going to form will be of length odd. So in those two cases, the pointer assignment will be a little different. For example, in even cases, left will be, if I am at index I, in even cases, left will be standing at index I and right will be pointing to I plus 1. Okay. And in odd cases, if in odd case, if I am at index I, in that case, left pointer will be at I and right pointer will also be pointing to the same pointer I. Okay. And then after that, they will try to expurge in either the left direction or in the right direction, considering whether they are the left pointer or the right one. Okay, let us come to the code. And the code is almost all also like extremely identical to 647. So it will be pretty easy for us to walk through it. So let us see what we are doing over here. The first thing that we are doing is we are declaring a variable called as answer, and it is something that we will return at the end. And it will contain the substring, which is the palindrome and which will be longest in our given string. Okay. And the second thing we are assigning is a variable of max length, and its value will be initially 0. Why are we doing that? Why did we need this variable? We need this variable because question asks us to return the longest palindrome. Okay, longest palindromic substring. All right. And in order to compute length, we must have a foundation length, the base length, the premise, right? And in this case, the comparison will be done with the help of max length. Okay. And then we start to iterate and scan the entire string as, which will be bounded with an order of n, this entire loop, this first loop. Okay. And then we have two cases, the odd case and the even case. The odd case and the even case. In the odd case, I pointed the pointer left and right to iterator I. And then we have certain conditions that left pointer should be within the bound of left and right pointer must be also within the bound of the right and the values must be equal at the left pointer and the right pointer. And if that is the case, then we ask, hey, the current substring status that we have and the length of that string, is it greater than or equivalent to max length? We don't need equal sign over here, but just for safety, I've kept it okay. So if this condition satisfies that the current length that we have, if it is greater than the previous max length, in that case, what does it mean? It means our current status of the substring, which is a palindrome. Why? Because it passed these three conditions. And if that length is greater than the previous max length, whatever that could have been, it means we have found a new substring, which is a palindrome, which is this one, okay? And so what we must do, we must update our answer or answer, which is here. It will contain the actual length of the actual substring, which will be the longest palindromic substring in the current string. And if I encounter the current length to be greater than the previous max length, in that case, I will update my answer and I will assign it to this. Why am I doing r plus 1? Because in Python, if I'm slicing a string between any two pointer, left and r, and if I also want to include r pointer values, you must have r plus 1 because l dot r is not inclusive, it is exclusive. So in order to include r, I must do r plus 1. That is why I'm doing r plus 1 over here. And once the answer is updated, I must also update the max length and it will become the length of the window size or the substring size, which is coming from here, okay? And once I come out of this if block, I decrease the left by 1 and increase the right by 1, okay? And when I exhaust this odd case loop, I'll come to the even case. And in even case, my left pointer will be I and right pointer will point to I plus 1. Okay, cool. And the entire case will remain as it is. As the odd case, we are again making a comparison for the substring size from the previous max length. And if it succeeds, I will update my answer by slicing the string at that point. And then I will also update the maximum length by r minus l plus 1, which is coming from here. And then I will decrease left pointer by 1. I will increase right pointer by 1. Both of these things are happening outside of the if block. And once I have exhausted this entire both loops and the main loop, which is this loop, I'll come out of the loop and I will return answer, okay, which will contain the actual answer. Now, what is the time complexity? The time complexity, the main time complexity, it is coming from here, which is order of n. But within that, we have two different loops, the while loop and this while loop, okay? And these two different while loops, it will be contributing to time complexity by some factor. And that factor I have denoted by order of f. What is the value of f here? I will leave that to you, okay? Please compute it or please estimate it, okay? And as far as space complexity is concerned, so what is the space complexity? Space complexity, as you can see, it is coming from this answer and it must be bounded within order of n. Why? Because the entire string can itself be a palindrome, right? And if its length is n, so our maximum length palindromic string will be n, only when the entire one is the palindrome itself, okay? So yeah, that was all there was to this problem. I hope you understood it. I might have drove this problem explanation a bit fast, only because it is extremely identical to 647, which is the problem just before this problem. This one is LeetCode 5, and the previous one was 647. Okay, cool. Let us go to the LeetCode dashboard, and we'll try to submit the solution and see how it goes. I have already submitted a solution for this problem, so I'll just copy and paste my code, and I will run it down. And as you can see, the test cases has been accepted and it passes all of them. Okay, cool. So yeah, that was all there was to this problem. If you have any questions, please feel free to ask me in the comments. I will see you in the next video, maybe tomorrow. Bye.